Republic Day greetings to all. Maths Aspirants is a community of math students, teachers, research scholars across India, and we used to conduct several online problem solving sessions and online test series to help the students who prepare for different national level competitive examinations. As a part of the online problem solving session series, today we blessed to have Miss Kajal Sachdeva, a research scholar from Maharshi Dayanand University, Rohtak, Haryana. She will today discuss with us some topics related with ordinary differential equations. We already had 2 sessions on ordinary differential equations of first order. So Ms. Kajal will today focus on second order linear differential equations, especially with constant coefficients. Ms. Kajal is now pursuing PhD at MDU, Rohtak, Haryana, and she cleared many national level tests like CSIR NET 3 times and CSIR JRF with all India rank 53. Also, she qualified GATE examination and JAM examination. So, I am very proud to introduce Kajal to you, and I'm very sure that she's really a good resource person. Will be a good resource person for our program. I hope that today's session will be really fruitful to all of you. I express my sincere thanks and gratitude to Ms. Kajal for accepting our invitation and joining with us. I welcome everyone to this class. Welcome, Kajal.
Good morning, everyone. First of all, I would like to thank Sir for introducing me and also inviting me and giving me opportunity to share my knowledge with all of you. So I'm very blessed to be there. So let's start. In today's session, we are going to learn about ordinary differential equation with constant coefficient. Earlier series, you have learnt about the first order differential equation by Dr. Meerani ma'am, and now we are proceeding to second order differential equations. Here we are doing for a special kind, that is constant coefficient. So what is linear differential equation with constant coefficient? So a differential equation of the form, this particular type of form, a naught dny upon dxn plus a1 dn minus 1y upon dxn minus 1 plus up to an minus 1 dy by dx plus a and y is equal to q. Here a naught, a1, a2 and an minus 1 an all are constants and q is some function of x here. So this is the non-homogeneous part here. We can write the corresponding homogeneous equation just letting this equation equal to 0. For example, we have the equation d cube y upon dx cube plus 3 d2y upon dx square minus 6 dy upon dx plus 2y is equal to sine 5x. Here we can see this is the third order linear differential equation. Here the coefficient 1, 3, minus 6 and 2 all are constant, and this is the function of x. Sine 5x is in place of q. So we can call it as linear differential equation with constant coefficients. So in this type of equation, we use a operator d. So what is d? D is equivalent to d upon dx, a differential operator. So we replace this in our equation, like this is the equation. So this become d cube y plus 3, this become d square y minus 6, this become dy plus 2y is equal to sine 5x. Now we can take y common out. So this whole equation is some function of d into y is equal to that homogeneous part sine 5x. So every equation can be written as in this form. This particular type of equation with constant coefficient can be written as in this form. So based on this form, we have auxiliary equation. We are going to write auxiliary equation. What is auxiliary equation? It is just taking the corresponding homogeneous part equal to 0 and replace d by m. Just put d is equal to m. So here we have the equation. So when we put here d is equal to m, we get m cube plus 3m square minus 6m plus 2 is equal to 0. So this is our auxiliary equation. Based on this auxiliary equation, we can solve and find the root of this equation. Here we have 3-degree equation, so we get 3 roots. Likewise, if we are taking m order, so here is the m order equation and we will get m roots. So based on these roots, we have some solution for this equation. So for finding general solution of linear differential equation with constant coefficient, we find two parts. One is complementary function and second is particular integral. So what is complementary function? Complementary function is a function which satisfies the homogeneous part only, which is a solution of homogeneous part. F dy is equal to 0. So in this, when we find this solution, so just we are taking this equation equal to 0 and we will get the roots. So here we get 3. In the preceding example, we get 3 values. Likewise, we get n values. And based on these n values, we get the n constants. So in this, we get the n constant in general solution. And the second part is particular integral. What is the particular integral? It is that function which satisfies the whole linear differential equation with constant coefficient. Here, no constant will be used. So the complete solution will be CF plus PI, complementary function plus particular integrals. So in the coming slides, we will learn about how to find CF and how to find PI. So CF is defined as complementary function can be determined. Just put the homogeneous part is equal to 0, then replace d by m. That means find auxiliary equation, and by this auxiliary equation we will solve this, and after solving we get the m roots. Based on these m roots, these roots can be real, distinct, can be equal, can be complex, rational, anything can be possible. So on this basis, we have some cases. So case 1 is when roots are real. So let's take an example when we have real roots. So we have an example 2. Let's take an example 2 d cube y upon dx cube minus 7 d2y by dx square plus 7 dy by dx minus 2y is equal to 0. This is the given equation. We can see from here, this given equation is linear differential equation with constant coefficient. So first what will we do? We just write it in symbolic form as 2 d cube y minus 7 d square y plus 7 dy minus 2y is equal to 0. Or we can write it as 2 d cube minus 7 d square plus 7d minus 2 whole y is equal to 0. So just write now auxiliary equation. How we write auxiliary equation? Replace d by m. 2m cube minus 7m square plus 7m minus 2 is equal to 0. So we are to find the root of this equation. How we can find root? This is a 3rd degree equation. So first root can be find out by hit and trial method. So we can see from here, if we are putting m is equal to 1, so we get 2 minus 7 plus 7 minus 2. This will be cancelled out and we get 0. So m is equal to 1, its root. One root we have find. Now we are going toward finding other 2 roots. So using synthetic division, we can find other 2 roots. Put 1 is equal to here, then the coefficient of m cube, m square, m and the constant term. So by synthetic division, we can find, just write 2 into 1, 2 minus 5, then minus 5 into 1 minus 5, then solve it out 2, then 2 into 1, 2, that is 0. So we get one root is written as 1, m minus 1 is its factor. and these can be written as 2m square minus 5m plus 2 is equal to 0. So from here, we can just find the root of quadratic equation by making pairs. That pair whose sum is minus 5 and product is 4. So we can write minus 4m minus m plus 2 is equal to 0. So we get m minus 1, and from here, taking 2m common, m minus 2 minus 1, m minus 2 is equal to 0. So we get the m minus 1, and here m minus 2 is common, and here 2m minus 1 is equal to 0. So we get the three roots, 1, 2, and from here 1 by 2. Here we can see all the roots are distinct. So this is the case where m1, m2, mn all are distinct. And we can write in this case CF as C1 e raised to power m1x plus C2 e raised to power m2x up to Cn e raised to power mnx. So these can be written as solution. So we are going to write solution here. So solution is CF is equal to C1 e raised to power m1. This can be m1 e raised to power x plus C2 e raised to power 2x plus C3 e raised to power 1 by 2x. So this is the required CF in this equation. Here we can see we have the already a homogeneous equation. Which equation we have taken is already a homogeneous equation. So no pi can be found here, particular integral. So we get the complete solution as the complementary function. So the complete solution of this equation we have find here, which is C1 e raised to power x plus C2 e raised to power 2x plus C3 e raised to power 1 by 2x. Now moving further, if we have another cases like if we get the case here m1 is equal to m2 is equal to k, if two of the roots are equal and others are distinct. So equal roots can be written as, say this root is k, so we can write it as e raised to power kx or into with c1 plus c2x. So this is the same e raised to power kx, just we are making it two constant with here. So c1 plus c2 into x, the common e raised to power kx plus other can be written as in the similar manner as in previous example. So let's take a case of this type of equation. So here we have an equation like d4y upon dx4 minus dqy upon dx cube minus 9 d2y by dx square minus 11 dy by dx minus 4y is equal to 0. So this equation, firstly we write it in symbolic form, taking d by dx as d. So we get d4 here d cube minus 9d square minus 11d minus 4, and taking y common out is equal to 0. So this is our f of d. Replace d by m and write auxiliary equation as m4 minus m cube minus 9m square minus 11m minus 4 is equal to 0. So this is the 4-degree equation. How we can find root here? By hit and trial, can anyone tell what is the root here? Anyone? Just check if we are putting 1 here, so we get this whole negative which cannot be neglected by only 1. But if we are using m is equal to minus 1 here, so put it as m is equal to minus 1, we get 1 minus 1 cube is minus 1, 9 minus 1 square is plus 1, minus 11 into minus 1 minus 4, which is 1 plus 1 minus 9 plus 11 minus 4. So here we can see 13 and negative of 13, which will be equal to 0. So m is equal to -1 is one root. Now again you can do synthetic division and find the other roots in the similar manner as we have done in previous example. So we get its root finally as -1, -1, -1 and 4. These are the four roots we will find here. So this is for you. You can find here. Now we get the roots as real and distinct, not but equal. Here we have three roots as equal roots and one is different. So in this case, we can apply this formula. So we can have three roots equal. When we have three root equal, we write 1x and x square as combination, then e raised to power kx plus the different root in the similar manner. So the complete solution here we can write as c1 plus c2x plus c3x square e raised to power -1 into x. So minus x plus, this is a distinct one, c4 e raised to power 4x. So this is our required solution in this case. We can have another cases also, like we get root as alpha plus root beta, alpha minus root beta. It means rational roots we can have in conjugate pairs. Root beta, here beta is greater than 0. We are not taking it as imaginary, this is the real one. So these can be considered also as in real case. We can write the solution as the earlier case also. These are the distinct and real case. C1 e raised to power alpha plus root beta x plus C2 e raised to power minus alpha minus plus alpha minus root beta x. We can write like this, but here we have written in another form also. We can write it is e raised to power alpha x and in the bracket C1 cos hyperbolic beta x plus C2 sin hyperbolic beta x. So how we have written this? Let's take an example and then we will justify how e raised to power x can be written as also in form of cos hyperbolic and sin hyperbolic x. So we have an example for this. D2y upon dx square minus 4 dy upon dx plus y is equal to 0. So when we solve this example, write it is in symbolic form d square y minus 4 dy plus y is equal to 0. So we can write auxiliary equation just replacing d by m minus 4m plus 1 is equal to 0. This is the quadratic equation and we can find the root easily by the discriminant way. So we can write the root as m is equal to minus b plus minus root d square minus 4ac upon 2a, where a is equal to 1, b is equal to minus 4 and c is equal to 1. So it can be written as b is equal to minus 4 under root b square is 16 minus 4ac upon 2a. 1. So we get the root 4 plus minus under root 12 by 2, which is 4 plus minus. It can be written as 2 root 3 upon 2. So we get 2 plus minus root 3. So here the two roots are m1 is equal to 2 plus root 3 and m2 is equal to 2 minus root 3. We can written also it as 2 plus root 3 value is 1.713, so something 3.713. And this is 2 minus 1.713, it means 0 point something. So these are the distinct and real roots. The solution can be written as in same way. C1 e raised to power 2 plus root 3x plus C2 e raised to power 2 minus root 3x. But we have written here in cos hyperbolic and sin hyperbolic form. So how this can be written? How we have written in these type of equation? So for writing this, just separating this, e raised to power 2x into e raised to power root 3x plus C2 e raised to power 2x into e raised to power minus root 3x. Now what we can do here, just substitute the value of this and this. Here we have e root 3x How we can write e raised to power x and e raised to power minus x? See, e raised to power x is 1 plus x square by 2 factorial plus x cube by 3 factorial up to so on. Just separating 1 x square by 2 factorial x4 by 4 factorial. This is the expansion of cos hyperbolic x plus and x cube by 3 factorial separating, we get the expansion of sine hyperbolic x. So e raised to power x can be written as sine hyperbolic x plus cos hyperbolic x. So just replacing e raised to power root 3x as cos hyperbolic x place in root 3x plus sine hyperbolic root 3x, and likewise replacing e minus root 3x, that is cos hyperbolic root 3x minus sine hyperbolic root 3x. So just separating out and we will get the required answer. When we separate these, so here we have C1 e raised to power 2x cos hyperbolic root 3x, and also from here cos hyperbolic root 3x. So we can take common from here cos hyperbolic root 3x. C1 plus C2 both are here. So we will get the one term of cos hyperbolic root 3x, and another when we take common we get the sine hyperbolic root 3x, and e raised to power 2x whole common. So the required solution will become, which we want in our required form, e raised to power 2x C1 cos hyperbolic root 3x plus C2. This can be another constants also. So we will write C3, C4 as our constant will be changed when we separate sine hyperbolic root 3x. So this is our required solution which we have converted. So in this case, we can write the solution in sine hyperbolic cos hyperbolic form also, and can be written as e raised to power also. Both are the correct way. And at last, we have the next one way, which is when roots are complex. In case of complex root, we get the roots in conjugate pair always, as the equation have real coefficients. So in conjugate pair, we will write the roots in similar way, just alpha written as e raised to power alpha x, and as it is an imaginary part, so the required answer will be cos beta x and sine beta x. E raised to power alpha x into C1 cos beta x plus C2 sine beta x, and the another in the same way when they are real and distinct. So let's take an example of these kind of equation. So we have an example d4y upon dx4 plus a4y is equal to 0. So write first in symbolic form, we get d4y plus a4y is equal to 0. When we take y common, we get auxiliary equation as just replace d by m, m4 plus a4 is equal to 0. For finding root of these type of equation, we can write this equation in the form m square plus a square whole square, which is m4 plus a4 plus 2m square a square. So this will be subtracted from here. This can be written in this form. A plus b whole square is a square plus b square plus 2ab. Now again solving this, a square, this can be written as root 2m a whole square. So this is a square minus b square. How we write a square minus b square? We have the formula.
A plus b into a minus b.
Yes, good. So we have the formula a minus b, a plus b. M square plus a square is a and minus b, root 2m a. In the similar manner, a square, a plus b. So m square plus a square plus under root 2m a is equal to 0. So we can find from here, this is also a quadratic equation and this is also a quadratic equation. When we write each separately equal to 0, so write in its standard form, just taking this one minus root 2ma, then plus a square is equal to 0 separately, and m square plus root 2ma plus a square is equal to 0 separately. So in this, when we solve this just by quadratic formula, m is equal to minus b is root 2a plus minus under root b square 2a square plus minus 4a square upon 2a. And in the similar manner, these roots can be found. Minus b plus minus root d 2a square minus 4a square upon 2a. So from here, two roots can be found from first side and two can be from second side. So here we get the first root as root 2a plus minus root 2 is under root 2a iota upon 2 plus minus, and from here minus root 2a plus minus under root 2a iota upon 2. So we get here two roots as under root 2a plus minus under root 2a iota by 2. So we get the imaginary roots here in conjugate pairs also. So we can write it as a upon root 2 just divided by this plus minus 1 upon root 2 a iota, and in the similar way minus a upon root 2 plus minus a iota upon root 2. So firstly write these equation roots. CF is equal to, just write e raised to power, this is the real part, a under root 2 x, and in the bracket we have c1 cos 1 by under root 2a plus c2 sin 1 by under root 2a. And similarly we can write this also, the solution of this, just plus e minus a upon root 2 x c1 cos 1 by root 2a plus c3 and c4 now because c1 c2 has been taken already, sin a upon root 2 x. So we have the required solution of the given equation. So here we have discussed the case when roots are complex. In the similar way, when these roots are if repeating, the two roots are alpha plus iota beta and another two roots are alpha minus iota beta. So in this case, we can write just a complementary function as e raised to power alpha x and repeating root as c1 plus x c2 cos beta x plus c3 plus x c4 sin beta x. So all the types of roots are discussed here for the complementary function. We can see from here. Now, determination of particular integral. How we find particular integral? We know that particular integral is just the solution of this equation, the homogeneous, also non-homogeneous, combined solution. So if we replace y, just y replaced by 1 by fd into q. When we take y as this, cancelling, and we get the right hand side is equal to left hand side. So for finding particular integral, we just 1 upon fd into q. We just apply this formula. So based on q, we have different criteria to find pi. When q is equal to e raised to power 2x, it means the right hand side part of given equation is e raised to power ax. So in this case, we just replace d by a. Just replace d by a, nothing else. But when we are replacing by a, the denominator should not be 0. If it becomes 0, then 1 upon 0 will be infinity and we cannot find the solution in this case. For this type of case, we have another way. When f of a is equal to 0, then in this case, what we do, just multiply by x and the derivative of denominator f dash, then put a in there. So we just find one time derivative and multiply it by x. Now here can also be possible f dash a is equal to 0. It can be possible. The derivative is also 0. So what would we do in this case? Now we will again multiply the equation by x. Now it becomes x square and take double derivative e raised to power ax. So we will repeat the procedure until we didn't get denominator equal to 0. So here we have the criteria for solving when q is equal to e raised to power ax. Let's solve a question based on that. q raised to power ax. So we have a question in this d2y upon dx square plus 6 dy upon dx plus 25y is equal to 104 e raised to power 3x. So just we are here finding particular integral. Complementary function can be found in the same way, just equal to 0, put this equal to 0 and make auxiliary equation, replace d by m, then find the value of m, and m will tell how the roots are real, distinct or complex. Based on that you can write the CF. So our focus is now on finding PI. So how we find PI here? Just write f of d first. So in symbolic form we have f of d, d square plus 6d plus 25. So we have the formula for PI 1 upon f of d into q. Here q is 104 e raised to power 3x. So writing f of d is d square plus 6d plus 25 and q is 104 into e raised to power 3x. So here we can solve it as this is the form of e raised to power ax. Just replacing a by 3 here, d by 3. Yes. So replacing 104 e raised to power 3x. When we replace d by 3, we get here 9, 6, 3, 18 plus 25. So it can be sum and equal to 27 plus 25, that is 52. E raised to power 3x, cancel out by 2. So we get 2 e raised to power 3x. So this is our PI, and for complete solution we just write CF plus PI. So CF can be found in a similar way, plus PI we have found here 2 into e raised to power 3x. So this is the way for finding when we have q is equal to e raised to power ax. So let's take a case of failure also when f of a is equal to 0. So let's take an example for this. So we have a question on this d2y upon dx square minus 6 dy upon dx plus 9y is equal to e raised to power 3x. So in this case, when we find a CF, we find CF d square minus 6d plus 9 is equal to 0. This is the symbolic form and equal to, this is a symbolic form only. And when we find here auxiliary equation is m square minus 6m plus 9 is equal to 0. And here we have the root m minus 3 whole square is equal to 0, which we can written. So m is equal to 3 and 3. We have the root as 3, 3, 2 times of this homogeneous part. So what we are doing here for finding PI, just written FD as denominator and putting D is equal to 3. This will be replaced 3. And we know that f of 3, what we have did, we just put m in place of D. So what are the roots will satisfy this equation, f of D. So when we will put f3 even 1 time, 2 time, this will be 0. So this is a case of failure surely. We can see from CF also. So in this case, how we proceed? We just take the derivative and multiplying it by x. 1 upon d square minus 6d plus 9 into e raised to power 3x. So put d is equal to 3, we will get 9 minus 18 plus 9, which is 0. In case of failure, we get just to take derivative here. When we take derivative and multiplying it by x, derivative is 2d minus 6 with respect to d, e raised to power 3x. Again, when we put 3 here, 6 minus 6 is 0. Again, case of failure. So here we multiply again it by x, it becomes x square, and taking derivative we get 2 e raised to power dx. So this is our required pi in this case. So we have here complete solution. CF can be written as both the roots are equal. So CF will be written as C1 plus C2x into e raised to power 3x, and plus when we do pi, then plus x square by 2 e raised to power 3x. This is our complete solution in this case. So moving further, this is the case when we have taken e raised to power ax type equation. Now we are taking the case when we have sin ax plus b or cos ax plus b. So in this type of equation, when q is sin ax plus b, we just write pi 1 upon fd sin ax plus b. Replace d square by minus a square here. What we do, we just replace d square by minus a square here. And if it 0 here, if the denominator becomes 0 after putting this, so just we will do as we have done in preceding case, multiplying it by x and then derivative, then put d square is equal to minus a square. So the only difference in both cases is, in the earlier case we just replace d by a when we have e raised to power ax, and when we have sin ax plus b, in this case we just replace d square by minus a square. When we have 2 times 0, when we have f dash d also 0, so again derivative x square f double dash d square minus a square sin ax plus b. So in this case, we have just a simple example. We are going to proceed with an example in this case. So we have example of a question. Any doubt till now?
No, ma'am.
Okay. So we have a equation d2y upon dx square plus dy upon dx plus y is equal to sin 2x. So first of all, write this equation in symbolic form. Just d square plus d plus 1 into y is equal to sin 2x. So for finding pi, we just write it as 1 upon f of d square plus d plus 1 into sin 2x. This is the value of q. Here is the case of sin ax plus b, where a is 2 and b is 0. You can see here. So what we will do in this case, d square replaced by minus a square. It means replaced by minus 4 simply. So when we replaced it by minus 4, we get d square minus 4 plus d plus 1 into sin 2x. So here we have the, yes, we have the 1 upon d minus 3, d, and minus 4 plus 1 is minus 3 sin 2x. I think this is not the here complete solution because we have d in the solution yet, and we have the only option is to putting d square is equal to minus a square, d square is equal to minus 4. So what we will do here, just rationalize it, multiplying by this equation d plus 3 above and below both, by denominator and by numerator both. We get d plus 3 into sin 2x, and below we get a minus b, a plus b is a square minus b square, d square minus 9, where d square is equal to minus 4. So as we have told earlier, what is d? When we take d with sin 2x and plus 3 sin 2x and put d square is equal to minus 4, we get minus 4 minus 9 is minus 13. D stands for differential operator, d by dx. So keep that in mind. D will be replaced by d by dx, and when we have 1 by d, we just simply replace it by integration. Whenever we have only d, then we replace it by d by dx, and we have 1 upon d, we just replace it by integration. So do the derivative of sine 2x. What is the derivative? 2 into cos 2x plus 3 sine 2x upon minus 13. This is the required pi in this case. So proceeding further, this is the case of sine ax plus b. Now the third case is q is equal to x raised to power m, where m being a non-negative integer. So when we have a polynomial type function, we can say this is power of x, so x powers function. What we do, we just take common the lowest degree term from f of d. We have f of d as a symbolic form, which is the power of d's. So we can have the constant term. If we don't have constant term, we have the d raised to power 1 term. So taking the whichever is lowest degree, taking that common. So after taking common, in place of that lowest degree term, we have 1 plus some function of d. And what we will do then, we will take this upper side and then this become whole inverse. And here we have the expansions to use. So let's take an example, and by this we will do this case. What we are saying, we are going to use some expansion. So let's learn some expansion here. Then we will proceed further. So we have the expansion of 1 minus d inverse. So this expansion is similar as 1 minus x whole inverse, which is 1 plus x square plus x cube up to so on. In the similar way, the another expansion is 1 plus d inverse. 1 plus x whole inverse, which is 1 minus x plus x cube. So alternate sign and write in the earlier case, similar way. In the another expansion can be 1 minus d power minus 2. This can be found by just taking a differentiation of this both sides. We will get the required expansion. Taking this differentiation, we get minus 1, 1 plus d raised to power minus 2, and taking the differentiation this side also, we get 1 plus 2d plus 2d plus 3d square plus 4d cube plus up to so on. So these 2-3 expansion you have to learn already, so that we can apply in this method. So let's take an example of this method. So we have example. The example is d2y upon dx square minus 4y is equal to x square. So first of all, we can see here the q is x square. Q is of form x square. So x raised to power m type. This is the non-homogeneous part here. So write first the symbolic form, which is d square minus 4 from here. So for finding pi, we have 1 upon f of d square minus 4 into q. Q can be replaced by x square. Now what we have said here, taking lowest degree term common. So we can see from here the lowest degree term is the constant term here. This is the term. So taking minus 4 common, we are left with here 1 and here minus d square by 4 into x square. What we did next here, just taking inverse. So how we can take inverse here? One second. Yeah. We have 1 minus d square by 4 inverse into x square. So we have minus 1 upon 4. The expansion of 1 minus this can be whole x inverse. So 1 minus x inverse expansion is 1 plus x square plus up to so on into x square. So write expansion only up to that term which is required by seeing this q. Here q is x square. So when we do first time derivative, we get 2x. When we do again derivative, we get 2. And all further derivatives are 0. So up to second time derivative, it will give non-zero, and all other cases it will give 0. So write up to only second. So here 1 into x square, d square upon 4 into x square plus d4 upon 4 into x square up to so on. So we get here x square and 2 time differentiation. D square means 2 time differentiation of x square, as d stands for 1 time differentiation and d square stands from 2 time differentiation. So when we do 2 time differentiation of x square, we get 2x 1 time and then again 2. And here we will do 4 time differentiation of x square. So which is obviously 0, as we have seen from here, only 2 time derivative is possible, and further we get 0. So another all terms are 0. So we get minus 1 upon 4 x square plus just cancel out 1 by 2. This is required pi in the given case. So likewise, we can find any solution of pi when we have e raised to power x form, we have sin ax plus b form, cos ax plus b form, or x raised to power m form, or their combination also. If we get a combination of these, just apply 1 by 1, find pi, then combine them. We will get the required answer. Now the another case is more special case, when we have some function e raised to power ax into some another function of x. V is here stand for some another function of x. It can be polynomial function, it can be any function. It is a product of two functions. What is e raised to power ax and the another is some function of x. In this case, what we do, just taking e raised to power ax earlier, then replace d by d plus a, replace d by d plus a and into v, then apply this operator on v only. So this is the case here. Let's take an example. We have a question of based on this example. The question says d2y upon dx square plus y is equal to x e raised to power 2x. So this is the question, and we will write first the symbolic form as d square plus 1. Now the pi is given by 1 upon f of d, d square plus 1 into x into e raised to power 2x. So now what you can see here, this is the form of type e raised to power 2x into x. So when we have equation of this type, e raised to power ax into some function of x, this can be v and this is e raised to power ax. What we do, just taking this earlier e raised to power 2x and replace d by d plus a here 2, d plus 2 whole square plus 1 into just keeping x. So e raised to power 2x, below we get d square plus a square plus b square plus 2ab plus 4d plus 1 into x. So we can solve further like in the preceding manner. Just what we have did in the case when we have some power of x function. Here d square plus 4d plus 5 into x. Taking lowest degree term common and solve further, we will get the required answer as we have did in previous case. So left for you. Now the last one case is one more case we have, special case we can discuss. If we have a equation of type where we are to find particular integral of q is given as x into v. One function is fixed, one is x and second is some function of x. It can be any function v of x, but multiplying it by x only. So in this case, we can just do taking x firstly, then 1 upon f of d, applying on v only, then addition, derivative of d by derivative of d upon dd of function 1 upon fd into v. So this is the formula. This is quite a difficult formula, but you can apply it very easily. Just we will do x taking preceding, then 1 upon f of d into v plus what we will do, just the derivative of this into v. So let's take an example of this type of question also. So we have a question d2y upon dx square plus 4y is equal to x into sin x. So here we can write first it into symbolic form. F of d is equal to d square plus 4. Now pi can be written as 1 upon f of d into x into sin x. So this is the function x into some function of x, v. This is x and this is v. So what we will do in this case, we just taking x and then 1 upon d square plus 4, then sin x plus derivative of this. Derivative of this is minus 2d upon d square plus 4 all square into sin x. So this is our case now. We just simplify this. How we can simplify? We have the formula for sin ax. Replace d square by minus a square. Minus 1 square. So replace d square by minus 1. We will get x is equal to, 1 second. Yes. We will get x is equal to 1 upon minus 1 plus 4 sin x. And here also replace d square by minus 1 square. Minus 1 plus 4 into sin x. So we get the answer here as 2d upon 9 sin x. So what stands here? D is for differentiation. So sin x differentiation is cos x. So this is the required pi in our case. We can have one more formula which is for journal any case. When we have any case, when q is any function of x, we can apply this formula in anywhere on any type of non-homogeneous part q given. But this is the quite difficult and also lengthy. It is lengthy also. So we can skip that formula, but for knowledge, you can learn 1 upon f of d into q. So in this case, what we will do, factorized f of d. We just write d minus alpha. As we know already the roots m1, m2, m3, so we can write d minus m1, d minus m2 into d minus m3. So when we write as a linear factor, so we can solve this as just written in integration e raised to power minus alpha x into q into dx and the outer side e raised to power alpha x. So one by one solve firstly this integration, then again break it into linear factor which will be left, then again apply this formula, and similar way we can find the final formula. This can be applied in all the earlier cases also. This is a journal formula, but we will not discuss this in today's lecture. Maybe by next lecture this will be discussed. Now we will discuss some previous year questions. So we have some previous year questions also from IIT and GATE examination, NET examination. So first question we have here, if yt is the solution of differential equation y double dash plus 4y is equal to 2e into t e raised to power t, then limit t tend to infinity e raised to power minus t yt is what? We are to find the value of this. It can be 2 by 3, it can be 2 by 5, it can be 2 by 7, or it can be 2 by 9. So first of all, see, it is R type of equation. This is the equation with constant coefficient, and also this is the non-homogeneous part in term of t. No problem. The independent variable here t in place of x. So how we find solution? We want the solution first, as we want yt, then multiplying it by e raised to power minus t, then applying limit t tend to infinity. So we find the solution of this equation first. So how we find solution? We find CF, then PI, then the complete solution will be CF plus PI. So just find CF. So for this, first we write it into symbolic form. So firstly write it as d2y by dx square plus 4y is equal to 2 into e raised to power t. So which can be now converted into symbolic form. B square plus 4 y is equal to 2 into e raised to power t. So this is the homogeneous part. So for writing auxiliary equation, replace d by m. We get m square plus 4 is equal to 0. So what are the roots here? This can be written as m minus 2 iota m plus 2 iota is equal to 0. This is the 2 iota whole scale. So m minus 2 iota m plus 2 iota. We get the root as 2 iota and minus 2 iota. M is equal to 2 iota and minus 2 iota. So by this, we can write CF. Here the roots are imaginary and conjugate pairs. So here we have real part missing. So real part is 0. 0 plus 2 iota, 0 minus 2 iota. So in place of real part, alpha is 0 here. So e raised to power 0x into C1 cos 2x plus C2 sin 2x. So we have here e raised to power 0x is 1, C1 cos 2x plus C2 sin 2x. So this is a CF. Now for finding PI, PI is equal to 1 upon f of d into 2 raised to power et. Here the independent variable is t. So not write x, just write t in place of x. Fd is d square plus 4. So write in place of pi as d square plus 4 into 2 e raised to power t. So in this case, we have the first one case e raised to power 80 type cube, where a is equal to 1. So replace d by 1, we get 1 upon 5, 2 into e raised to power t. So we get 2 upon 5 e raised to power t. So here we have the complete solution with us C1 cos 2t plus C2 sin 2t, that is CF plus PI, 2 upon 5 e raised to power t. This is the P. So this is the y. And in question, what they want? They want e raised to power minus t into y of t, limit t tend to infinity. So just multiplying y by e raised to power minus t and taking limit t tend to infinity. So y into e raised to power minus t. Multiplying it by c1 cos t2 e raised to power minus t, c2 sin 2t e raised to power minus t, 2 by 5 e raised to power t e raised to power minus t. This will be cancelled and applying limit t tend to infinity. Limit t tend to infinity. So when we apply limit t tend to infinity, e raised to power minus infinity is 0. 0 into something bounded. As you know, cos function is bounded between minus 1 to 1 if we are taking real function, and c1 is also bounded. So this is a bounded into 0. So we get first part 0. Similarly, we get second part also 0. And here t is not here. So when we apply limit, it will be remain same 2 upon 5. So we get the required answer as 2 upon 5. So let's see options. So here the option number B is correct. The B option is 2 upon 5. So this is our first question. Now moving towards the second one question. Yeah. So second question is, let yx be the solution of differential equation d2y Let yx be the solution of differential equation d2y plus 5 dy by dx plus 6y is equal to 0. Here also the initial conditions is given. Y0 is equal to 1 and derivative dy by dx at x is equal to 0 is equal to minus 1. So by these conditions, we can also eliminate constant. We will get the particular solution here. And what they have asked yx attains its maximum value at x is equal to what? This is a numerical answer type question. Directly they want answer. So in this question, we also find yx first. Then on the base of yx, we find maximum value is where. And for finding maximum value, we have the method of calculus that is second derivative test. So we will apply this in the end. So here we have the equation of type constant coefficient equation d2y by dx here plus 5 dy by dx plus 6y is equal to 0. So this is the equation with constant coefficient and only homogeneous equation here. There is no non-homogeneous part. So here we are only to find CF. By the CF we will get our required solution. So write it is into symbolic form d square plus 5d plus 6. Y is equal to 0. So from here we can write auxiliary equation as, so auxiliary equation is equal to m square plus 5m plus 6 is equal to 0, which can be factorized further 3m plus 2m. Its sum is 5 and product is 6. So taking m common, m plus 3 plus 2, m plus 3 is equal to 0. So from here, m plus 3 into m plus 2 is equal to 0. And we get the value of m as minus 3 and minus 2. It is the case distinct roots real. So we can write its solution very easily. C1 e raised to power 3x plus C2 e raised to power minus 2x. So this is the complementary function which is also equal to the complete solution here because we have the homogeneous equation here. Also the given condition is y0 is equal to 1 and y dash 0 is equal to minus 1. So y0 is equal to 1 and y dash 0, the derivative of x at x is equal to 0. Matlab y dash 0 is equal to minus 1. So just put these values, y0 is equal to 1 and y dash 0 is equal to minus 1. y0 is equal to 1 and y dash 0 is equal to minus 1. Put these values, we will get firstly y0 is equal to 1. So y is equal to 1 when x is equal to 0. It will become C1 plus C2 is equal to 1. So first equation is this, number it as 1. And now take derivative because as we are to put in derivative 0. So y dash x is equal to minus 3c1 e raised to power minus 3x minus 2c2 e raised to power minus 2x. So just put a 0 and write minus 1. Y dash is equal to minus 1 and put a 0 e raised to power 0 1 minus 2c2. This is our second equation. So now from here we can eliminate C1 and C2. So there are many methods to solve C1 and C2. First is Kramer rule also can we apply here. We can apply elimination method here. So apply elimination method. Just multiply first by 2. So we get 2c1 plus 2c2. Now the second and the new equation can be add. Just add these. This will be cancel out and this become minus c1. This become minus 1. Plus 1, sorry, plus 1 as 2 minus 1 is 1 and adding we are, so minus c1, we get c1 is equal to minus 1. If c1 is equal to minus 1 then put it in back in equation what? 1 is equal to c1 is minus 1 plus c2, this gives c2 is equal to 1 plus 1 that is 2. So c1 is equal to 1 and c2 is equal to 2. c1 is equal to minus 1 and c2 is equal to 2. We get the required solution replace C1, C2 value in our solution. So we get in place of C1 minus 1 and this 2. So 2 into e raised to power minus 2x and here minus e raised to power minus 3x. So just writing the solution. We have y of x is equal to 2 e raised to power minus 2x minus e raised to power minus 3x. So in this question, they have said find the maximum value, or at what point we get the maximum value. For what value of x we get the maximum value of these functions. So this is the function of x. And we know the second derivative test. What is the second derivative test? Just put first derivative is equal to 0. We get x is equal to some point. And at that point, find double derivative. If second derivative is greater than 0, we get minimum value. If second derivative is less than 0, we get maximum value at that point x naught. At that point x naught. So just apply second derivative test on this. We find y dash x here. So how we can do derivative? Just minus 2 minus 4 e raised to power minus 2x plus 3 e raised to power minus 3x here. Put it equal to 0. We get 4 e raised to power minus 2x is equal to 3 e raised to power minus 3x. And also can be written as taking 4 e raised to power minus 2x in division e raised to power minus 3x is equal to 3. So we get e raised to power minus 3 is upon plus 3 minus 2 is x. E raised to power x is equal to 3 by 4. Or we can write x is equal to log of 3 by 4. So this is a single point we get from here. And also we will check the second derivative. The second derivative here is positive or negative. If it is negative, then we get the maximum value. So just apply second derivative here. Y double dash x, 8 e raised to power minus 2x minus 9 e raised to power minus 3x. Just put this point here. It will become 8 into e raised to power is 3 by 4 raised to power minus 2 and e raised to power x is 3 by 4 raised to power minus 3. So solve this, we will get negative. You can easily solve this. Just a reciprocal of this, we get 8 into 16 by 9 and here 4 cube is 64 upon 27. Just multiplying, we will get all over negative. Just calculate. So this is the point of maximum value. So at this point, we get the maximum value. So just you have the calculator in your exam. You can see from the top right corner, we have calculator given. So find this value log 3 by 4. We will get the required answer. As numerical answer type question required up to correctly 2 or 3 points, they will tell you in exam. Just read the instructions. So we can write our final answer in decimal structure also. So this is the question. So we will get log 3 by 4 is our answer, or you will calculate, it will say minus 0.288 is our answer. So any doubt till now?
No, ma'am.
Okay. So moving to our third question. So we have the third question as, if yx is the solution of initial value problem, this problem where y0 is equal to 2 and y dash 0 is equal to 0, here y dash 0 is equal to 0, you are to find the value of y of log 2, round off to 2 decimal places. So this is also a very simple question. Just like previous one question, here we are to find yx first. Then we replace x by log 2. So how we can find yx here? Just we have the given equation as d2y by dx square plus 4 dy by dx plus 4y is equal to 0. This is our equation. We can write this equation in symbolic form, d square plus 4d plus 4 is equal to 4. This is our symbolic form. And then write auxiliary equation, as this is only the homogeneous part equation, so CF will be required solution. This is f of d here. So write it into symbolic form. M square plus 4m plus 4. This is auxiliary equation. And from here we can see this is the perfect square equation. M plus 2 का whole square. M square plus 4 plus 4m is equal to 0. So we get m is equal to minus 2 minus 2. This is the real and equal roots. So in this case we have CF is equal to C1 plus C2x into e raised to power minus 2x. And the CF is also the required solution y. But here we have C1 and C2, which can be eliminated by using initial problem. So initial problem we have y0 is equal to 2 and y dash 0 is equal to 0. So y0 is equal to putting y0 C1 plus here 0 e raised to power 0 1. So we get C1 is equal to 2. And the derivative of this equation y dash x is equal to C1 plus C2x as it is, u into v rule, minus 2 e raised to power minus 2x plus, now e raised to power minus 2x as it is, and derivative of this is C2. Just put y dash 0 is equal to 0. 0 is equal to minus 2. This is 0, C1 plus e raised to power 0, 1. This is C2. So C1 is equal to 2. Put C1 is equal to 2, we get minus 4 plus C2. So C2 is equal to 4. We get C1 is equal to 2 and C2 is equal to 4. So put this back in the solution. C1 is equal to 2 and C2 is equal to 4. 4x e raised to power minus 2x. So this is our required solution. But what they have asked about y into log of 2. So just replace x by log 2, we will get the required answer. So y of log 2 is equal to 2 plus 4 log 2 into e raised to power minus 2 log 2. So 2 plus, you can find log 2 value by calculator, and then this can be written as e log 2 power minus 2. E log cancel out, 2 into log 2 and divided by 2 square, that is 4. So this will be your required answer. When we just find log 2 value and put here, we will get the required answer. And the answer will be equal to 1.19. You can calculate it very easily. So this is the question in also numerical answer type question. Now moving to our next question. So our next question is a very good question, I would say. This is a different and good question. Let x plus ex and 1 plus x plus ex be solution of linear second order ordinary differential equation with constant coefficient. What they have said, these three are the solution of second order ordinary differential equation. We know that in second order ordinary differential equation, we have two constants, C1, C2 by the CF, and the particular integral can also be found, and here no constant we get in particular integral. So how we can judge the two constant will where we put in these three solutions, which is the PI in these three solutions. So we have two methods to do this. One is long method and one is shortcut. So first we will go towards the long method. So we have a result when we have say second order differential equation, A naught, even any order differential equation with constant coefficient. I am taking here second order, but you can take journal degree equation. But we are saying if y1, y2 is solution of this equation, solution of first, then the linear combination will be solution. क्या homogeneous equation में is in homogeneous equation c1 y1 plus c2 y2 is also its solution? This is a question for you. If y1
Yes,
and y,
ma'am.
yes,
Yes,
but
ma'am.
yes. So let's check. Let's check it is solution or not. Just if it's solution, then it will satisfy the first. So put this back in first equation. So this, I would say y will satisfy this equation. Double derivative c1 y1 double dash plus c2 y2 double dash plus a1. Single derivative c1 y1 dash plus c2 y2 dash plus a2y. Y is c1 y1 plus c2 y2 into c1 y1 plus c2 y2 is equal to f of x. We have this after substituting. If it is solution, then if y is equal to c1 y1 plus c2 y2 is solution, that it will satisfy first. Now collecting y1 terms,
Ma'am.
a naught c1 y1 double dash, a1 c1 y1 dash. Yes,
Ma'am, if x has to be 0, if these are, that is just the linear combination of two solutions is also a solution, then if x has to be 0.
Yes, you can say if the equation is of type homogeneous. If homogeneous equation, then any combination can be solution. But I am here saying fx is not equal to 0. We are taking non-homogeneous part also. So in this case, we want a condition which make it a solution. Okay, we are finding a condition which will make this linear combination to be solution of non-homogeneous equation also. In case of homogeneous equation, we get any linear combination as a solution in this type of equation. But when we have non-homogeneous equation, we are to stop and we are to find a condition which will make it a solution. So we are going to add to find that condition. So how we will find? Just collecting y1 terms and now collecting y2 term. A naught c2 y2 double dash plus a1 c2 y2 dash plus this one a2 c2 y2 is equal to f of x. As you have said, y1 and y2 its solution. We are taking already y1 and y2 is solution. So this will satisfy a naught y1 double dash a1 y1 dash plus a2 y1 is equal to f of x. We know that. And also y2 be its solution. So y2 double dash plus y2 dash plus y2 is equal to fx. That also be fx. So we can substitute these both value here. So when we take c1 common, we get a naught y1 double dash a1 y1 dash plus a2 y1, which is equal to f of x plus. Also from here, when we take c2 common, a naught y2 double dash plus a1 y2 dash plus a2 y2, which is also fx, and here also fx. So we get, when we take fx common, as we are saying fx is not equal to 0, we are taking. Right now, if fx is equal to 0, then it will satisfy. We can see from here, if fx is equal to 0, then equation is satisfied. Left hand side also 0, right hand side also 0. But if fx is not equal to 0, if we are taking non-homogeneous part here, then c1 plus c2 should be equal to 1. That means the linear combination should be equal to 0 when we are taking any journal type of equation with constant coefficient. Okay, so the linear combination would be solution if the combination is 1. The sum of that combination c1, c2. If we have n solution, then c1, y1, c2, y2 up to cn, y1 is the journal solution of the nth order linear differential equation with constant coefficient if summation ci is equal to 1. C1 plus C2 plus Cn is equal to 1. So that is our case. In this we have given 3 solutions of second order differential equation. So if these are solution, then the combination is also solution if the constant taken as some 1. So if we are taking C1 into x, C2 into second solution x plus Cx, then third constant must be 1 minus C1 plus C2. Am I right?
Yes, ma'am.
Yes, clear na? C1 cancel out by C1, C2 cancel out by C2, then we get 1, sum as 1. So we are taking the solution as this, C1x plus C2 into second plus another one is equal to this. Or we can solve it further. How we can solve? Just 1 minute. So we get y is equal to C1x, C2 into, next solution is x plus Cx plus C3 into, C3 place we get 1 minus, once again, 1 minus C1 minus C2 into 1 plus x plus e raised to power x. So we get C1 and x term also here, C2 plus x term also here, 1 minus C1 minus C2, this whole x plus constant term is here also, yes, here is the constant term 1 minus C1 minus C2 into 1, and another term is e raised to power x type. So e raised to power x type is C2 plus e raised to power x type from here 1 minus C1 minus C2 into e raised to power x type. So we get here C1 to cancel out, we get only x here. Here we get 1 minus C1 minus C2 into 1 plus here C2 cancel out 1 minus C1 into e raised to power x. So we get x into some another constant, say a into 1, some another constant, say b into e raised to power x. So we get the solution as, we can take solution of their linear combination as C1 into 1, C2 into e raised to power x plus x. As we are saying, we have second degree equation. So surely we have two constants. At last we have seen here, we have two arbitrary constant and one is the part of particular integral. Here x is the part of particular integral. So this is the long method. But if we are going to apply short method, because in exam we have very less time. So according to this, what we will do in this case, we have to write a solution which generate all the three solutions which we have here. So we know that we have here x, ex, 1. We have these three type of Li and their combinations are written here. Their combinations are written here. And here we can see x is fixed in all the three cases. Here x is fixed in all the three cases. So x is not changed. So which is not changed, we will take it as part of Pi. And another can be C1 into 1 and C2 into e raised to power x. So these solution can be generated by these equation. How? If we want to write x, we just put C1 and C2 is equal to 0. Here C1 and C2 is any arbitrary constant. So when we put C1 and C2 is equal to 0, we get x only. And the next one is x plus ex. How we get x plus ex? Just put C1 is equal to 0 and C2 is equal to 1. We get x plus ex. And in the similar way, when we get 1 plus x plus ex, just put C1 is equal to 1, C2 is equal to 1. We get 1 plus ex plus x. So this is a technique to write a solution which generate all the three solutions. So we can do by our manual method also or by this short trick, as you like. So this solution we get. Now we are just to put these conditions so that we get the value of C1 and C2. Then we get yx here and we put 1 only. So just apply the condition y0 is equal to 3 and y dash 0 is equal to 4. y0 is equal to 3 and y dash 0 is equal to 4. y0 is equal to 3 and y dash 0 is equal to 4. So when we put y 0 is equal to 3, so it's 3 and 0 put करेंगे, then C2 and x0 will become 0. So we get C1 plus C2 is equal to 3. And the next one is taking derivative. So y dash x is equal to 0, constant derivative is 0. Here C2 e raised to power x plus 1. So we get y dash 0 is equal to 4, C2 plus 1. So we get C2 as 3, and when C2 is equal to 3, then C1 is equal to 0. So we get the final solution as C1 0, C2 3 plus x. And we are to find the value of y of 1. As question said, find the value of y of 1. So put x is equal to 1, we get 3e plus 1. So we have the required answer, 3e plus 1. So let's see what happened. 1 minute. Yes. So we have the option 3e plus 1. So the required answer is option B there. So this is a question, a very good question. Now moving to next question.
Ma'am, can you repeat once, ma'am?
Yes, we can repeat this question. First of all, remember a result. Any solution of linear differential equation with constant coefficient, which homogeneous part and non-homogeneous part both are given. Their linear combination will be solution if the convex combination is 1. If C1 plus C2 plus Cn is 1. If y1, y2, yn are solution of nth order linear differential equation with constant coefficient, then their combination C1 y1 plus C2 y2 plus Cn yn is its solution if C1 plus C2 plus Cn is equal to 1. We are saying that. So on based of this, in this question we have given x, x plus ex and x plus 1 plus x plus ex. These three solution of second order linear differential equation. So second order linear differential equation must have two constants. So based on this, we know in this case the combination when we write the solution, their sum must be 1. So if we are taking C1 with x, C2 with x plus ex, then the third one must be 1 minus C1 minus C2. So we have just did this. Yes, here we have C1x plus C2 into this 1 minus this. Just solve it out collecting constant term, x terms and e raised to power x term. When we collect this, x have no constant, with 1 we have constant and with e raised to power we have constant. So we get the general solution. General solution we have the two constant a and b, and this is the part of pi. So in shortcut method, I have told you to just take that part of pi which is in all the three cases, which are repeating in all the three cases. So we have here x in first also, x in second also, and x in third also. So this can be considered as pi, and other 1 and e raised to power x can be written as with constant. So we have write the solution in a very quick way. But I would say you can go also by this method which we have did earlier. So this is the solution. And now you can find the value of constant by using y of 0 is equal to 3 and y dash 0 is equal to 4. You will get the complete y. And after that put y1, we will get the required solution. So is it clear?
Yes, ma'am. Thank you.
Okay. So moving to our next question. Yeah. So next question is yx is equal to lambda e raised to power 2x plus e raised to power beta x, where beta is not equal to 2, is a solution of this differential equation, satisfying y dash 0 is equal to 5 and y0 value is equal to what? 1, 4, 5, 9. So it is a quite easy question, I would say. You are to just find the solution and compare with it. because the solution is given, but here lambda and beta are unknown. So we can see from here in symbolic form we can write it as d square plus d minus 6 is equal to 0. This is a symbolic form. Or we can write auxiliary equation as m square plus m minus 6. So by this we are not to even find root, because one root is given 2 e raised to power 2x, so one root must be 2. One root must be 2, so just apply synthetic division. When one root is 2 already known, so 2, 3, 3 to the 6, 0. The next root is m plus 3 is equal to 0, m is equal to minus 3. So in a very quick way, we get the both root. One is 2 and another is minus 3. When one root is 2 and another is minus 3, real and distinct root. So in this case, we can write our solution as yx is equal to c1 e raised to power 2x minus c2 plus c2 e raised to power minus 3x. We can write it as this. So comparing this with this solution, y is equal to lambda ex plus e raised to power beta x, and here beta is not equal to 2. They have clearly told you beta is not equal to 2. It means beta cannot be compared with this one result. Cannot compare with first equation because beta is not equal to 2. So this first must be compared with this and second term compare with this. So we get after comparison C1 is equal to lambda, first of all, both must be equal, and C2 is equal to 1 as no constant is here. So C2 is equal to 1 and beta is equal to minus 3 after comparison. So we get yx as basically lambda into e raised to power 2x plus C2 value 1 e raised to power minus 3x. So we get yx as this. Now lambda is also should be eliminated here. So how we can eliminate? By using this condition. Y dash 0 is equal to 5. So y dash 0 is equal to 5. So first we find y dash x, which is 2 lambda e raised to power 2x minus 3 e raised to power minus 3x. So y dash 0 is equal to 5. Just put 0, 2 lambda minus 3. So we get 5 plus 3, 8 is equal to 2 lambda. Lambda is equal to 4. We get lambda is equal to 4. So we get the final solution as lambda is equal to 4 e raised to power minus 3. We are to find the value of y is equal to 0, x is equal to 0, y0 is equal to 4 e raised to power 0 plus e raised to power 0, 4 plus 1, that is 5. So let's check our options. Yeah, we have the option 5. So the correct answer is C, that is option number 5. This is an easy one question, but here the comparison is important. Lambda and beta values should be known. So now one most, I think, good or important question we can say. We are to find particular integral of differential equation this. What is a differential equation? Y double dash plus 3y dash plus 2y is equal to e raised to power x. So we have to find particular integral here. So symbolic form is d square plus 3d plus 2 into e raised to power x. So anyone tell, did we apply any case in this type of equation? Have we done this type of case?
Ma'am, take e to the power x equal to t.
Okay, then what happened? How you will solve that? Here f of d should be replaced by anything. Okay, so this is for x. D is written on behalf of d by dx, not d by dt. So that, or if you want to change ex is equal to t, then change here. But when we change here, so this will not remain constant coefficient equation. So this is a very different case. Yes. Anyone
Ma'am,
else?
combination of cos hyperbolic and sin hyperbolic.
Combination of cos hyperbolic, sine hyperbolic. That case also sine of hyperbolic ex and cos hyperbolic ex. Then again, we will not get any of the case which we have discussed. We have discussed a journal method. Yes, but journal method is quite difficult, as I said. So we will solve this equation in a very different way. Let's see how we will solve this equation. When you get any these type of equation, then you can do one thing, just convert second order equation into first order equation. How you can convert? Just starting from here. We can write as symbolic form d square plus 3d plus 2 into y is equal to e raised to power x. So now this can be break down into two parts, d plus 1 d plus 2 y is equal to e raised to power x. This is the product of these two functions. Now you can put these as complete z. Let d plus 2y is equal to z. We are converting our equation from second order to first order. Just replacing d plus 1, this can be replaced by z. This is converted into z, e raised to power x. Now our dependent variable is z and independent variable is still x here. Now you can see this equation of what type? If I would write dz by dx plus z is equal to e raised to power ex. Have you discussed the solution of these type of equation? Yeah, I will make a remind. This is a linear differential equation of that kind of form. Dy by dx plus p into q is equal p into y is equal to q. Here integrating factor would be e raised to power integration p dx, and then the final solution is y into integrating factor is equal to integrating factor into q dx plus c. We have did in our previous lectures by Dr. Milirani ma'am, I think. So just apply these. As we can see from here, z is dependent, x is independent, and the equation is linear differential equation. Here p is 1 and q is e raised to power x. So integrating factor would be e raised to power integration 1 dx. So we get e raised to power x as integrating factor. Now the solution can be written as z into, as dependent variable is z, integrating factor integrating factor is e raised to power x into q is e raised to power x dx plus c. Here we get the solution for z. But how we would solve this? Here we put ex is equal to t for solving this integration only. So when we put ex is equal to t, ex dx is equal to dt. So ex dx is equal to dt, and this will be converted into et dt plus c, z into ex. So we get here z as e raised to power t, integration is e raised to power t, and e raised to power t then converted again t as e raised to power x. So we get z is equal to e raised to power minus x plus c into e raised to minus x. This is the value of z, but we are to find value of y. One second. Yeah. So we are to find the value of y. So how we can find y here? Just take the value of z. Yeah, we have substituted z is equal to d plus 2 into y. So just substituted back d plus 2 into y is equal to e raised to power x, e raised to power minus x plus c, e raised to power minus x. Now again, this can be written as dy by dx plus 2y e raised to power x, e raised to minus x, c into e raised to power minus x. So this is again a linear differential equation of first order. Here this time p is equal to 2 and the whole is q. Q is some function of x. So again integrating factor we will found e integration p dx, which is e raised to power 2x, and the solution is y into, now dependent variable is y into integrating factor is integrating factor into q, e raised to power x, e raised to power minus x, plus c e raised to power minus x, the whole is q, dx plus take this time c1, constant as c1. So we get our solution as e raised to power 2x and e raised to power minus x is ex, e raised to power ex differently with dx, plus the next part c into e raised to power 2x into e raised to power minus x is e raised to power x dx plus c1. So here again we are on same, ex is equal to t, substitute, we get e raised to power ex like in preceding, plus here we get the integration c ex plus c1. So we get y into e raised to power 2x is equal to this. So y is equal to e raised to power minus 2x, e raised to power ex, c e raised to power minus 2x, c1 e raised to power minus 2x. So this is our final solution. But they have asked only about pi. So can anyone tell me by this equation, by this solution, what is pi here? Particular integral is what part?
First term.
Yeah. Yeah, very good. First term is our pi here because this contains constant and constant always contain in the complementary function. This is independent of constant. So this is our pi. So let's check in our answer which would match with our answer. Yeah. So e raised to power minus 2x, e raised to power ex is the answer number B. So this is our answer. So anyone, if any doubt, then they can ask in this.
Ma'am, we can also do this by partial fraction.
Yeah, you can do by partial fraction. Then in this case, you have to apply the journal method, which we have discussed. We didn't do the example. So this is alternate for journal method. Okay, you can do by a partial method. Then e raised to power ex is the main problem here. For this, we don't have any particular method to find particular integral. So we have to go on journal method for this. The journal method, when you apply partial fraction, then e raised to power minus alpha x into e raised to power e 2x. You can see, you will just complete it by yourself. If you will get any problem, then you can contact me by journal method. Okay.
Yes, ma'am.
Okay.
Ma'am, if we use method of variation of parameters, we will get the answer.
Yeah, we will do variation of parameter in the next class. Okay. So we will solve this same question by variation of parameter also. Yeah, you can solve by this method also.
Okay, ma'am. Thank you.
Okay. So the next question or our last question of this lecture, a particular integral of the differential equation this. So we are to find only particular integral in this differential equation. So we can write this differential equation in symbolic form, d square minus 2d into y is equal to e raised to power 2x into sin x. So now for particular integral 1 upon f of d, d square minus 2d into q. We have did a method for these kind of q. If anyone remember, we have done 1 by f of d e raised to power ax into v, which can be written as e raised to power ax f of d plus a into v. So we are just applying this e raised to power 2x first, then d plus 2 will be put here, d plus 2 square minus 2 d plus 2, and at last sin x as it is. So we get here b plus 2 square, that is a square plus b square plus 2ab, then minus 2d and minus 4 into sin x. So plus 4 minus 4 would be cancelled, e2x upon d square plus 4d minus 2d, that is 2d into sin x. So here now just we have to solve this one. So d square would be put as sin ax is d square minus a square. So d square minus 1, just put, we will get minus 1 plus 2d. It means 2d minus 1 sin x. Now again, like in preceding manner, we can just rationalize 2d plus 1 below multiply, and by denominator also, numerator also. So we get e raised to power 2x, 2d plus 1 into sin x, and the lower side we will get 2d minus 1, 2d plus 1 as a square minus b square, 4d square minus 1. And again substituting d square is equal to minus 1, we get e2x. Here d square is equal to minus 1 is minus 4 minus 1 minus 5. And above 2d sin x plus sin x. So d can be operated as differentiation. Sin x differentiation is cos x, 2 cos x plus sin x. This is our required PI. Let's match with our answers. Minus e raised to power 2x upon 5, 2 sin cos x plus sin x. So C is the correct answer in this case. So anyone, if have any query regarding today's lecture about constant coefficients, linear differential equation with constant coefficient, then now they can ask.
Good morning, ma'am. Thank you for your lecture. I actually enjoyed it very much, and there are a lot of problems, and it helped me a lot, ma'am. Thank you, ma'am.
Thank you, Diya. Thank you so much.
Diya, please.
Actually, ma'am, I am from West Bengal. I am doing my M.Sc. I am from Iritty Bhubaneswar, and I am in my first year.
Oh, very good. Nice.
Thank you. Yeah, thank you, Diya Saha. Thank you.
Thank you, sir.
Yes. Others, please come forward and talk.
Hello.
Yes. Yes, Didi.
Hello, ma'am. I am T.T. Viswas from West Bengal, and I am a first student from T.T.
Didi is from NIT Trichy and she is from West Bengal.
Okay, sir.
Thank you, madam, and thank you, sir. Very good lecture on this Republic Day, and happy Republic Day to all. I want to ask you some books and what device you are using for writing on screen also.
Okay, so first of all, happy Republic Day to you too and everyone. So some books you can follow SL Rose books for differential equation, or MD Raisingani book for practice of questioning, or you can also go through from the books you like. Just read any book of differential equation, and I'm using Pentab. It's, you can take any brand, it doesn't matter which you are using, just take anyone.
Okay, thank you, Dharmendra. Elizabeth Joy? Yes. You're muted.
Hello, ma'am.
Yes.
Ma'am, my name is Elizabeth and I'm from Marthanesius College, Kodamangalam, and I'm a BSc student. Ma'am, today's class was very helpful for me. Actually, we have already learned these topics in our last semester, but I think today's class was very useful to get a very clear idea about the topic, and it gave more information about more than what we already learned. and it also helped to refresh the area related to differential equations. And thank you so much, ma'am. Thank you for spending your valuable time for us. Thank you.
Thank you,
Thank you,
Elizabeth.
Elizabeth.
Yeah, Elizabeth is from Kerala.
Okay.
Okay, any
Hello.
others? Yes.
Good afternoon, ma'am. Myself Lakshmi. I'm a third year basic student from Kerala. Actually, I really enjoyed your class because this topic is one of my favorite topics in mathematics, and I already studied this topic in our last semester. Mm, but this session really helped me to understand the topics once again, and also to sum up the portions which we studied in our college, and also to understand some new concepts about the topic differential equation, especially the section from particle integral, because some categories regarding this topic we haven't studied in our college. So this session helped me to understand that also, and also the problems that also really helped me to go forward with this topic. And thank you so much, ma'am. Hoping to get more classes from you. Thank you, sir.
Thank you.
Thank you,
Thank you so
Lakshmi.
much.
Anyone else? Yes.
Hello, ma'am.
Yes.
Am I audible,
Yes.
sir?
Yeah, you are audible.
Yeah. Yes.
Hello, ma'am. My name is ʟɪᴇᴏᴜ. I'm from Maharashtra. I just have completed my MSc from IIT Bhubaneswar. Ma'am, I have a doubt. Like I'm preparing for CSIR NET now. The problem with the differential equations that in exam, like to solve the differential equation problems, it takes little bit more time as compared to the pure theoretical subjects. Like we have to solve it completely to find the answer. Most times. So like, how did you tackle the problem? Like, how did you solve in less time in your exam? Like, how did you attempt? What's your approach?
Okay. So first of all, yeah, it's quite lengthy than other subjects, but you have to just practice more and more. Your speed will be increased automatically. And secondly, you can see the options first. See what options want. You can just direct approach to that only. You are not to find the complete whole solution. Just see what options want, and according to that, many times we cancels many options. Just see by the question what is. So these approach can be used for reducing the time, and short tricks. There are so many short tricks for solving differential equations also. So learn that many. So you will be definitely, and practice more and more. This subject requires practice. And advantage of this subject is when you solve and you get the answer. And you surely know in the exam also ki I am doing the right thing. And it is the right answer definitely. In case of pure mathematics, you will always in confusion that what I'm taking is right or not. But in case of differential equation, you are sure about that my answer is correct. So this is the beneficial, I would say.
Yes, ma'am. Right.
Thank
Okay,
you.
thank you.
Thank you, Mayuresh. Thank you. Somebody else started to talk. Rasa, please.
Yes. So yes, sir. Hello, ma'am. Happy Republic Day. I am Raza from Ranchi, Jharkhand, and really it gives me a very useful knowledge about particle integral, because I have a lot of confusion in that. So thank you so much. Thank you, sir, also giving such an opportunity. Thank you. That's all.
Thank you, Rasa. Any others?
Good morning, sir, and also good morning, madam.
Yeah. Yes.
Which is one of the useful session, madam, and also which is useful to who are preparing for further studies, NET, GAME, JAM, GATE, whatever it may be. Thank you, madam. Thank you, sir.
Kashi, could you please introduce?
Yes, sir. My name is Kashi. I am from Hyderabad, Telangana state.
Thank you. Thank you, Kashi. Somebody else also started? Yes. Yeah.
I'm Mukta from �Oʞᴏᴜᴜ College of Maharashtra. I'm a final year BSc student. This lecture was really very nice. Madam, you covered most of the parts of second order linear differential equation, and it was very helpful. And thank you, Vinod sir, for arranging such sessions regularly. Thank you.
Thank you, Mugdha.
Thank you.
Tarun, you can speak.
Hello, ma'am. I'm Tarun Pano from Tamil Nadu. Your lecture is a very good and clear-cut answers, explanations, ma'am. In the NET exam, we have a multiple answerable question. What about this linear differential equation, multiple answerable questions? Is there any examples? If it is, we are expecting next lecture.
Tarun, possibly the problems from differential equations will be of seeking the solutions, and in many cases you will have only one answer. So I am not seeing that much questions in multi-select type from OBE.
Okay.
Kajal, you can add something if you have something to say.
Yeah, next time in next lecture, I will surely add some multi-select answers type question also. So you will get an idea about that also.
Yeah.
So I will definitely add in next lecture.
Okay. So any others? Thank you, Tarun. Any others? So I think let us wind up here, as Kajal has some other class on 12 p.m. So I hope that our next session will be possibly on the next Sunday. We will announce it through our groups after scheduling it. So once again, thank you, Kajal, for helping our students. I'm very happy that your first class in our platform is really very active with good responses and active participation from students all over India. Thank you very much, Kajal.
Thank you so much, sir, for giving me chance and sharing my knowledge with very talented student. Even I'm saying they are very nice.
Okay, someone else is also trying to speak. Yes, Yogesh. Yogesh, you can speak.
Thank you, sir, and thank you, ma'am, and good noon to all, to both of you. Sir, I have just completed my MSc from DU, and I am from Haryana.
Okay.
Thank
Once again,
you.
thanks.
Yeah.
Yes, bye.